Any questions that the Big Bang Theory didn't answer. Why you look in different directions and things look the same in different directions. But there are many questions that the Big Bang Theory does answer.
For example?
For example, the universe is expanding. When we look in any direction and we measure now the background radiation from that early expansion, we see that it's uniform across the sky.
Which is predicted
by Big Bang Theory. And there's no other explanation for it at this point. When we look at the abundance of the lightest elements like hydrogen and helium, we can predict how much would be formed during the Big Bang. And we go and observe as experimentalists and see how much there is.
How close are you?
Very close.
What's very close?
To within a few percent.
Really?
Better. Yeah.
Wow.
It confirms what is predicted by Big Bang Theory.
Wow.
There's another success which segues into the anthropic principle. We're all charmed by these accidents, that if the charge of the electron was a little different from what it was, the life would be, if not non-existent, at least very different. But in our accelerator collisions, which we're trying to replicate the early universe, we make equal amounts of matter and antimatter. So the nature seems to be
antimatter being matter with having opposite charges.
Charge.
So if you got them together, they would disintegrate.
They would annihilate.
Since that didn't happen.
It didn't happen, and what happens, in fact, is that the Big Bang Theory, with the necessity of a cooling process, show that a slight excess of quarks would be left over, and that's us.
And that's the prediction. That's amazing.
What is remarkable about this?
Is this a unique time? There's so much happening now. In the next 10 or 15 years, you're getting your pictures are literally getting right back to the origin. Is the next 10 or 15 years something special, or have people always said that? What do you think?
I'm sure people have always said it to some extent, but it is a unique time in cosmology and in astronomy. We have now the Hubble Space Telescope above the Earth's atmosphere, which allows us to look further back than we've seen before. We have new satellites that will go up and measure the background radiation from the Big Bang to 1 part in, 0.001% accuracy, which all of these theories make predictions, which are now at the point where they're going to be tested with new data. And it's not one single experiment. It's particle physics experiments and big accelerators. It's satellites above the atmosphere, large ground-based telescopes. And all of these are closing in a way that has not been possible before. So I think it's not unrealistic to say.
It's really an exciting time.
I would compare this time perhaps with the pre-Columbian epoch in development of geography. We did not know that America does exist, okay? And after it was discovered, it was done. We have a map of our Earth. So right now, in the next 10, 15, 20 years, perhaps we will have a map of the part of the universe which we can, in principle, see, which is about 15 or so billion light years. And in the next 5 billion years, this map is not going to change. So we are participating in an event which we are waiting for 15 billion years. It just wait 15 years more, it will happen.
Good.
Well, one of the unique things about astronomy is that you can see the history because you're looking back in time. And geologists don't have that on the Earth, and archaeologists.
Yeah, our machines are time machines.
They are
we
time
build
machines.
A particle accelerator as a time machine.
But let's never forget that there are parts of the universe which are outside our entire past light cone. Those we will never see until we move, as Andre said, far into the future.
Or look with some other mechanisms that Nancy might have
Or
heard
wormholes.
Well, let's just remember that although this program was introduced as a discussion of creation, what we're really talking about here is what it was like at the very, very beginning, whether that was laws of physics or a vacuum or whatever. And that's not answering the question of creation. Why is it there? Why is there something rather than nothing?
We have to take a final question, which is a prediction for the future. 100 years from now, will theories of inflation or multi-world interpretations of many universes be commonly accepted? I think I know your answer, but...
Oh, yes.
Oh, yes. Leon?
I tend to be optimistic along those lines, although I agree that I will say yes, but I won't bet too much on it.
Nancy, how do you view it?
Let me give you a theological rationale for saying that it will be. Augustine, in the 5th century, developed what he called the principle of plenitude, and that was his explanation as to why we have the sorts of beings in the universe that we don't particularly like, such as mosquitoes, as well as the ones that we do, like dogs and horses.
And Leon.
And I think that that same principle, when you think about it, leads you to expect that there would be more universes than just the one that we can measure and observe.
That's an expansion of traditional theology,
Yes,
for sure.
if there is a God and God cares about creating, then why would God stop with just this one little bubble?
Right?
I'll agree that there will be in the future a general belief in the many universes, simply because it's an automatic consequence of quantum mechanics, which I think is a correct theory. I don't think, however, the inflation model which Andre is defending will be around, because I don't think you need it to explain the universe. All you need are the standard laws of physics.
Wendy?
I think it's quite possible. I think it will have to be put to experimental test, which is the difficult question. But in the same way as we've moved our thinking from the sun to the galaxy to the universe expanding, it doesn't make sense that there would just be one necessarily. So, but I'd like to see the experimental evidence.
Well, I hope you find and show it to us. Regarding the beginning of the universe, I guess there are only three little questions: when, how, and why. Let's start with when. The best estimate is about 12 billion years ago for our universe. But we've heard that chaotic inflationary cosmology would create multiple universes beyond our wildest imagination. As for how, we come to the anthropic principle and the belief that our universe may be specially suited for life. It is the dawn of a new millennium, and the time is good to ponder ultimate issues. As for why this universe began, sometimes only silence gets us closer to truth. I'm Robert Kuhn.